Now, symmetric and skew symmetric matrices. So let's first discuss what a symmetric matrix is. If we have a square matrix A, and it is basically the square matrix A is symmetric if the transpose of A is equal to A. So if you take the transpose of matrix square matrix A, it will remain the same. So see these examples. Now see this matrix here. If you take its transpose, so basically change this row into a column and change the second row into a column as well, you can see that it is basically the same. There is no change. So this is a symmetric matrix. Now there is another way to determine if a matrix is symmetric or not. You just outline the principal diagonal. Elements in the principal diagonal we are not concerned with, because if you take the transpose of a matrix, the elements in the principal diagonal will remain in the same positions. But the elements outside of the principal diagonal, basically this element and this element must be the same, this element and this element must be the same, this element and this element must be the same for it. So you can see a pattern here basically. So recognize this pattern and see this matrix here. This is a 4 by 4 symmetric matrix. How? See this is the principal diagonal. Now basically you will ignore the principal diagonal. This element and this element, they're the same. This element and this element are the same. These two elements and these two elements, you can see that they're basically somewhat like, if you use a principal diagonal as a mirror, so you'll use the principal diagonal as a mirror, and on either side they must be the same. Now you see this and this, they're the same. -2 and -2 here, they're the same. So basically what you must remember is either you can take the transpose, and if the transpose is the same, it is a symmetric matrix, or you can just use a shortcut. You encircle the principal diagonal and use the principal diagonal as a mirror, and the images on either side of the principal diagonal must be the same, basically as you can see in the mirror, and it will be a symmetric matrix. Now, what is a skew symmetric matrix? If you take a square matrix A, it is called skew symmetric if the transpose of A is equal to -A. So see this matrix B here. Now, if you take its transpose, it basically becomes this. And then if you take -1 common from this B transpose, what it does is basically, this is matrix B, the original matrix B. And so this is a skew symmetric matrix. Now, Hermitian and skew Hermitian matrices. So a Hermitian matrix is let's just take a square matrix A with complex entries. Now basically a complex number is in the form A plus IB. Now A is the real component of the complex number and IB is the complex uh, part of the complex number. The imaginary, not the complex, the imaginary part of the complex number. Now, it is the square matrix A with complex entries is called Hermitian if the transpose of the conjugate of A is equal to A. Basically, the conjugate of A plus IB, if we had A plus IB, if this is the conjugate of A plus IB will be equal to A minus IB. So let's just see this matrix A here. Now it has two real numbers over here in the principal diagonal, and it has two complex entries. So basically, the conjugate of A, the real entries will remain real entries, will not change them, but the complex entries will take their conjugate. So basically, 1 minus I becomes 1 plus I, and 1 plus I becomes 1 minus I. So, if you take the transpose of A conjugate, it will give you, again, it will give you A. So, this is a skew, this is a Hermitian matrix. Now, Hermitian and skew Hermitian, we'll talk about skew Hermitian matrices. A square matrix A, we have a square matrix A with complex entries again, and it is called skew Hermitian if the transpose of A conjugate is equal to minus A. So, for example, look at this matrix here. Now, the conjugate of this, the zeros will remain zeros, and these complex entries 2 minus 3i will become 2 plus 3i, minus 2 minus 3i will become minus 2 plus 3i. So basically, in a conjugate, you'll just change the sign of the imaginary part of the complex number. Now, if you take the transpose of this, it will become this matrix, which is equal to, if you take minus 1 as common outside, it becomes minus 1 into the original matrix A. This is matrix A. So this is equal to minus A. Thus, A is skew Hermitian.